And welcome to this third edition of the Metrology Military for the Sea. This is once again, unfortunately, on as a web seminar, not in presence. We hope next year to have this in presence. So I now leave the floor to Professor Claudio Di Capua, General Co-Chairman of the conference, and the Professor Nicola Moraci, Vice Rector of the University of Reggio Calabria. So, professors, the floor is yours.
Good morning, ladies and gentlemen. As Vice Rector of Mediterranean University of Reggio Calabria, it is a great honor and pleasure for me to welcome all of you to this virtual conference. The good health of the sea is fundamental for the survival of the humanities and of the planet. And monitoring is a key tool that allows us to understand the sea health. And I think that Metro Sea conference will serve as a forum for researchers and industry engaged on this important and vital topic. I am sure that all of you will find the presentation interesting and stimulating, and also the discussion fruitful. Now it's time to start, and I wish all of you to enjoy this conference. I hope in present next year, and I hope in our university. Thank you very much.
Professor De Capo.
Thank you. Good morning and welcome to the 2021 IEEE International Workshop on Metrology for the Sea. I am Claudio De Capua, full professor of electric and electronic measurements at the University Mediterranean of Reggio Calabria and co-organizer together with the Professor Pasquale Da Ponte, the Professor Fabio Filanotti, and the General Dario Nicolella of this edition of the Metro Sea. This edition was originally planned to be held in the conference hall of the Renewmel laboratory of the University Mediterranean of Reggio Calabria. The Renewmel laboratory is built in a strategic geographical position in front of the Messina Strait. The Renewmel laboratory is a building in wood of 600 square meters with a sea area of about 3,000 square meters. It was born with the aim to find a solution to enhance the energy availability of the territory in which it's aimed, and to provide the tools for advanced modeling at the sea. The laboratory carry out environmental studies and provides technical support in the field of environmental protection and pollution monitoring in marine environment. The main research interests are marine energy production, studies on marine and coastal morphology, sea pollution monitoring, coastal erosion, bathymetric studies, marine exploration, and physical modeling at the sea. For this purpose, the laboratory is equipped with a large set of instrumentation for monitoring the sea states and marine currents and monitoring the meteorological condition in our area. Furthermore, it is equipped with a mobile laboratory mounted on a craft, consisting of a single beam and a multi-beam interferometer sonar systems, which allow to perform bathymetric measurements and to analyze the morphology of the sea bottom in order to create maps and profile of the underwater relief. The craft can perform bathymetric studies and investigation on the marine morphology until 50 meters of depth. In addition, a laser scanner with a range of 1 kilometer allows to carry out accurate topographical measurements of the shoreline and seaside. Moreover, an inertial navigation sensor allows to accurate measure on the position and the setup of the boat. In the next future, an aero generator realized in cooperation with General Electric Avio will be installed in the sea area in front of the laboratory. The wind turbine is specifically designed to operate in marine environment. Furthermore, to complete the system, another turbine is being developed to produce electric energy from the kinetic energy carried by the marine currents. Unfortunately, because of the COVID pandemic, this edition of IEEE Metrology for the Sea will be held online. But despite all that, it still achieved a great success in terms of participation and the quality of the works submitted. Today we will have the preliminary session of military metrology for the sea, organized and coordinated by the General Dario Nicolella, President of the Armed Forces Communication and Electronics Association chapter of Napoli. In the afternoon, Morgana Vighi from the University of Barcelona will deliver the tutorial Emerging Threats for the Marine Environment. And for the first time at Metro Sea, we will have a round table dedicated to the education on metrology for the sea. Giovanni Battista Rossi from University of Genoa will moderate the round table. The round table is focused on allowing discussion among well-known experts, providing international perspective and highlighting innovative solutions and common approaches in the field of education in metrology for the sea. In conclusion, I would like to say thanks to everyone for participating at the 2021 IEEE International Workshop on Metrology for the Sea. Thank you.
Okay, thank you very much to Professor Moraci and De Capa for their introductory remarks. Before I go on, I would like to thank all the participants, the speakers, and the Italian Navy per the patronage given to this conference. This is also the chance for me to give some information about AFCEA. So I'll try to okay. Can you see the video?
Yes.
Okay. Okay. This is the program of the morning. Not very long, but I think very interesting. But of course, I'm not the authorized person to say that. This is something that has to be said by the audience. Okay. What is AFCEA International? Where, well, it's a place, it's a forum where industries meet the government needs. So AFCEA is a non-profit international organization that was founded in 1946, right after the Second World War, as a technical forum to discuss technical issues in contrapositions with the Eastern Bloc. In these years, AFCEA has helped members advance information technology, communications, and electronics capabilities. As of today, the association is structured in 140 chapters, which are located in more than 30 countries, and it counts more than 30,000 individual members and more than 1,500 corporate members. It means companies, academics, governments, and so on. This is the presence of AFCEA in the world. As you can see, is not only related to the NATO nations, but is also something out of the nations. There is something in the Far East and Australia or South America. This is the situation in Europe and also in Italy. Well, in Italy, we have 3 chapters, Naples, Rome, and Aviano. Aviano is mainly related to the presence of the US Air Force Base. Rome is one of the largest chapters in the world. They have more than 500 members, so it's really a big one. Naples is an historical chapter. It was founded in 1961, and it was the 3rd chapter in Europe after Paris and London. It is mainly related to the presence of the NATO base in Naples. So this was maybe the reason why I was chosen to be the president of this chapter. And I'm really proud of being and honored of being the president of this chapter, because in the past, the admiral, the commander of the NATO base, was the president. Why join AFCEA International? Well, if you are a member of AFCEA, you can regularly interact with the professionals who come for several environments, like military services, government agencies, academia, and corporate members, which means big industries, normally, in the field of the national, international defense, intelligence, and the security industry. How to join AFCEA? Well, you have 2 possibilities. First one is contact our secretary, who is following the conference, by the way, I saw him, at secretaria.afcea.naples.it, or directly go to the website and select the membership menu, then the about the membership, then individual benefits, and join. And then fill the individual membership applications. So let's go back to the program. Now it's the first speaker now is are the first speakers. So I leave the floor to Lieutenant Terracciano and Bazzarello from the Naval Support and Experimentation Center in La Spezia. So the floor is yours.
Good morning, everybody. I'm going to share my presentation. Maybe. Okay. So I'm Lieutenant Lorenzo Bazzarello. I will present Boomer project for naval multi-influence signature measurement, the key role of unmanned vehicles to reduce mine risk. I will present also in behalf of Lieutenant Daniele Terracciano. So this is the summary. The first point is how to reduce the mine risk. Then an explanation about Boomer and the work that is in progress. Then Boomer, especially for multi-influence signature, and the conclusion. So I apologize for the very brief introduction, but we have some time constraints, so I need to very summarize this point. To reducing the mine risk, obviously we use mine countermeasure, and they can be divided in active and passive. So the active one intend to localize or destroy the threat. So using, for example, Minesweeper or Minehunter, and the passive one has the aim to confining or avoid the threat and reduce possible damage. And this is the point in which we want to focus for this work. So confining and avoiding the threat. Nowadays, to reduce this kind of risk, military ship, especially military ship, intend to reduce acoustic and magnetic signature, and they can do this before testing their signature in acoustic or magnetic testing area. And then with some intervention in the permit station or in the with the changing some particular engine, and so this is to reduce the acoustic and the magnetic signature. But the problem of this is that there are very few testing areas in the world. In Italy, we have 2 of that area, but every ships need to do this. So it's not very easy to do this. And also every ships need to do this periodically because could be some, for example, the biofuel in the shaft of the ship that can change the acoustic signature. So now we have also to consider another important factor, that mine are in continuous evolution. And so the acoustic and magnetic test area were supposed to consider acoustic and magnetic and sometimes also pressure sensor of mine. But modern mine can also has photodiode, underwater electric potential sensor, extremely low frequency effect sensor, seismic, and so on. So there are some the acoustic and the magnetic part that is well known, but there are other part and other signature of the ship that are never checked, and so it's a possible risk. So the gap to fill that we want to fill with this project is that we need a flexible and expeditionary and easy to deploy testing range to ensure effective monitoring and continuous monitoring in every part of the world and at the right time. And also, we need a system that can easily integrate new sensor because mines continues evolve and use new sensors. So now I'm going to introduce Boomer, and then we will focus the problem on the signature part. So Boomer is a project financed by National Armament or Directorate, the Italian National Armament Directorate, Segredifesa, and is the study and the development of a system of autonomous and reconfigurable system to enhance the test and evaluation capability of the CSSN for underwater warfare. So this is a list of the all possible scenario that we will we are developing in Boomer. And so with this, we can cover a very wide spectrum of possibility and of testing capability. At the moment, the first batch of the project that was the feasibility study is was concluded in 2020, and on September 2021 we started the second batch. So the second batch is the development and implementation of demonstrator at TRL 6. So the first, the 2.1 batch is the procurement of subsystem, and the last batch is the software development and the final test at sea. That will be held on April of the next year. This is some example of the vehicle that we will use for Boomer. They are small vehicle that can be deployed by a RIB, and they are modular and reconfigurable. So in a few hours, we can change the complete suite of payload mounted on board and use this vehicle for one or for another purpose. And these are some of the scenario that will be developed. So, for example, they can be used for acoustic signature and to check the sonar performance. For calibration of sensor, for example, hydrophone, to track and to check the precision of navigation. And the one we are interested today, that is the naval multi-influence signature. In particular, in this scenario, two vehicles we will be laying on the sea bottom. This couple of vehicles will mount a complete suite of sensor that can explore the UEP signature, the ELF signature, acoustic, magnetic, and so on. So, and in future can be also integrate other different sensor. To know exactly the position of this vehicle, we use at the beginning, at the end of the test, surface buoy, that is a system like this. So with an USBL, we can track the vehicle, know the exact position, and then start all the run of the ship. These are some of the example of the signature that we intend to register with this new system. So, for example, the underwater electric potential, that is the result from the corrosion and the anti-corrosion current of a ship, and is present in the ship and also in the submarine. So it's very important signal. And ELF, that is extremely low frequency effect, that is generated by electromagnetic field under the kilohertz. And so, for example, ripple in electronic circuit, or some galvanic current coupled with the rotating propeller shaft, for example. And this is also a very important signature because it can be detected very far from the ship. So, concluding, the new mines and new sensor are a sensible gap in mine warfare, especially for the protection of the ship. And a modular and easily reconfigurable system seems a promising solution to keep up with the new evolution of mines. So EUVs can be fast deployable solution to frequently monitor ship parameters and also to do this in every place of the world. So thank you for your attention. Feel free to ask me if you want some precision.
If there is anybody who wants to ask questions, please raise the hand so we can see. In the meantime, I have a question for you, which is not technical, but mainly, let's say, political issue. If I don't mistake, you are in the same base of the NATO CMRE, correct?
Yes, it's correct.
Okay, okay. I remember because we provided a service, IT service for them. Do you have any synergy with them? Because they are doing something really interesting with the undersea.
We have a memorandum of understanding with them, so we can use this memorandum of understanding with the precise scope. So, for example, we have automatic target recognition program with them, or a program with the acoustic for acoustic signature also with them. So we normally we work with them. Yes, it's
yeah, because they are customer funded, so they are really looking for customer to fund the projects and so on. Okay, thank you, Lorenzo, for your answer.
We also work with them during a demo, for example. On last September, we went on REPMUS, that is a NATO exercise in Portugal.
Mm-hmm.
And we cooperate with them to share some information on the same system. So it's very common. And
Dario.
Sì. Yes.
I have a question.
Yeah.
It is a curiosity for our speaker. Congratulations for the presentation. It's very, very accurate. And it is my curiosity. If a submarine is in the zone of water, probably this water is polluted by the presence of the ship. So is it possible to understand if in a piece of water, in a column of water, there was or not a submarine?
Yes, of course, it depends on the sensor that you have at the moment. So normally we use a vector sensor that can give the direction of arrival. At the moment we have only 2D vector sensor, but we are experimenting 3D, so also with the 3 axes. And so we can see the direction of arrival of the noise generated by a ship or something else, and knowing the frequency, the characteristic frequency of different system, you can see this is a ship or this is something else, for example. So it can be possible. With this project, we also try to see if we can say this with the acoustic signature and with something else. So the work is in progress, but offshore you can say if you are doing a ship signature and there is for example, a submarine, you can find the track of submarine in your system.
Yes, I understand the use of acoustic or something related to noise. But may I, there are some systems, also at a prototype point of view, trying to monitor the change of the chemistry and the physical parameters in the water due to passage of the submarine.
Yeah, this is the underwater electric potential, because the change of the chemistry is the result is the galvanic current, because the different pressure in the that the water makes in the different part of the submarine and of the ship generate a kind of galvanic current, and this can be detected by a sensor that is the result is the underwater electric potential. So this is the yes, for sure you can detect this, but we are starting to study this this approach. So I cannot say something for the future, but for sure you can do this.
Okay, thank you.
Before ending, I also want to give the to say hello from the Commander Stefani, that is my commander, and so the chief of underwater warfare in here in at CSSN La Spezia.
Okay, thank you, Lorenzo, and also my greetings to Mirko, to Commander Stefani also, and thanks for for your participation, of course, and thank you to you and Daniele for the interesting briefing. Okay, now we go on, and now we have Brigadier General Giovanni Savoldelli Petrocchi, who is going to speak about air urban mobility to support maritime environment, the Skygate project. Giovanni, the floor is yours. Okay.
Thank you very much, Dario. Let me show my presentation. Is on the video? No.
Not yet.
Not yet?
No.
Is in your video, my presentation?
I can see it.
Yes. Okay, try to start the full screen mode.
Yeah, okay.
Okay, that's fine.
It's fine. Thank you very much. Good morning to everybody. I will give you in the next 20 minutes a short presentation of Skygate project. It's an aeronautical specifically project, but I think that will be a lot of opportunities for the maritime environment. Advanced air mobility is a new form of aviation utilizing airspace above congested cities to better serve the public, business, disadvantages, communities, and emergency responders. Boeing company called OverMobility the third era for the civilian air force. We see this new technology providing more convenient transportation and delivery of goods, as well as jobs to indigenous cultures and remote communities. We note the importance of urban mobility being accessible to all, initially focusing on public safety and emergency response. Urban air mobility is a concept that proposes to develop short-range, point-to-point transportation systems in metropolitan areas or port area using vertical takeoff and landing VTOL or short takeoff and landing STOL aircraft. Through the strong technological innovation and the green transition, it has the double objective to improve the mobility intra-city and to offer alternative opportunities in the intra-connection city, intercity, with the use of eVTOL aircraft with the construction of a sustainable dedicated infrastructure. Initially, for eVTOL development, the airport will be the focus for passenger transport in the city center, nearby municipalities, attractions. Then we'll create areas within the city for intercity travel with eVTOL operators certified by EASA, it's the European agency. An example of this area could be the coastal city with well-equipped port areas where can be a place to operate with eVTOL to allow not only transport intercity, but also specifically for the maritime environment, goods or people from land on board or vessel at anchor. A study by Volocopter, an eVTOL Germany company. The others in the world are Lilium, Eang is a Chinese company, or Joby, a US company, or Vertical Airspace, a UK company. A study by Volocopter estimates an air urban mobility market opportunity worth 231 billion by 2035. 131 billion will originate by the passenger segment of eVTOL market. In addition to traffic management, regulations and certifications, the key driver for scalability and market growth will be pricing policies. Compared to the traditional vertical mobility, eVTOLs allow for low maintenance and operational costs. The advanced air mobility market is driven by enabling technologies derived both from the aerospace and automotive industries, together with the strong relevance of the urban planning and infrastructure development sectors. Aerospace and automotive have always been the key industries of the Turing economic system. Skygate. Skygate is the first advanced air mobility project in Italy. Skygate is a project with the aim to develop the first example of electric air transport for passengers in Italy, while testing new technologies and new service models designed for urban mobility and sustainability. Skygate's competitive advantage is the fact that our headquarters is located within the Torino Italia City Airport, right in the heart of an important European airspace district. Skygate in short. Skygate is a startup accelerator in the field of vertical electrical mobility. Skygate will support startups and scale-ups to get access to the market, which is traditionally complex, risky, and highly regulated compared to the other industries, by leveraging its aerospace expertise, its aeronautical assets and certifications. Skygate is a digital twin for designing, planning, virtually simulating, and replicating full air mobility ecosystem to be sold worldwide. A unique virtual simulation environment to test vehicles, infrastructures, technologies, and urban planning supported by ENAC, the Italian Civil Aviation Authority, and Politecnico of Turin. The first Italian Vertipot is located within the Torino Italia Airport. Skygate offers a validation and in-flight testing laboratory dedicated to all those innovative technologies that need to be prototyped and tested before entering the market. Air advanced mobility is not simply an extension of today's aviation industries. It will be enabled by entirely new products and services that will rely on investment and development. The advanced air mobility market is driven by enabling technologies derived both from aerospace and automotive industries, together with a strong relevance of the urban planning and infrastructure development sectors. Particularly, aerospace and automotive have always been the key industries of the Turin economic ecosystem. Exciting new technologies from lithium-ion batteries to lightweight electric motors, advanced composites, aircraft automation process, and safety systems enable safe, green, affordable flight, greatly expanding the mobility of people and goods. Proponents of urban air mobility anticipate the advancements in electric aircraft, automation, and telecommunications, driven by unmanned aircraft and automobile applications, may support the introduction of prototype systems and service networks as soon as 2020. The Vertipot is not an helipad. It's a new concept and design of infrastructure for electrical vertical takeoff and landing. The location of a Vertipot will be initially planned and realized near the intermodal transport nodes as metros, fairs, railway stations, logistics centers, bus stations, port area. Type of infrastructure will be eco-sustainable as materials, modular. It depends on single landing points or hub to optimize an intermodal transport system. Potential customers will be businessmen at the beginning, 2024-2026. After 2026, a low economic cost compared to taxi car. Social impact, ecosystem, efficient, safe, and sustainable air transport. Torino Italia Airport is the capital of Italian aviation, with an history starting just after the Wright brothers' flight. Since 2000, the airport has continuously expanded, also thanks to DigiSky in the R&D field. In 2009, our founder Maurizio Cheli won the world speed record with our innovative Sky Spark, the 100% electric airplane fully designed and developed by us. Torino Italia Airport is an international airport with ATC, air traffic control, run by ENAV. The airport covers more than 600 hectares that can host all the new infrastructures necessary to the development of a new advanced air mobility system. Experimental scenario. An agreement with City Council of Turin, Alba and Ivrea will be the first connections with eVTOL. Alba and Ivrea are industrial cities with some road and railway connections rather deficient. An air urban transport from Torino Italia or Torino Caselle, the main airport of Piemonte region, will allow to connect quickly the two cities. Skygate Turin offers an excellent scenario to validate technologies that will see different classes of aircraft and different modes of traffic management. No matter what the technology is, all aerospace innovations necessarily undergo different stages of development and certification, which are intrinsically stringent. The certification path starts from transfer of technology via prototype development with airworthiness check to flying rig and in-flight test with permit to fly and final certification of a dedicated unit through a flight test program. This kind of startup accelerator place are also already developed in some European countries, as in Ingolstadt in Germany, in Lyon in France, or in Cranfield in UK, or at the Schiphol Airport in Amsterdam. Partners of Skygate there are some institutional partners as the Polytechnic of Torino or Torino Airport. On the right side, there are some industrial partners, as Volocopter and Manta, that are the two eVTOL companies. But there is also D-Flight and ENAV for the ATM, for the air traffic management. At this stage, there are also some other negotiations with some specific company related to support the eVTOL in not only in Turin but around the world, related for electricity, mainly for the electricity, or for the design of the Vertipot. As advanced air mobility is a new form of aviation which makes practical and effective use of airspace above congested cities, let's have a look at the advantages in the maritime scenario. The first benefit is related to public safety and emergency response, for example, connecting a port area to the anchored vessels in harbors. In Hamburg and Amsterdam harbors, they have recently started to use drones to carry different items to the ships in the roadstead. This new way of forwarding goods shortens the commute and can be managed independently without turning to motorboats. There is a clear and big saving in time and staff which be employed otherwise. In Singapore, a Sky Sport company based in London and Los Angeles has signed an agreement with Volocopter to build a Vertipot at Marina Bay to connect the harbor area to the airport and to the islands of Singapore. The US Marine Corps is partnering with the Air Force on its Agility Prime initiative to encourage development of the commercial eVTOL industry. The partnership with the Air Force dovetails with the Marines' broader efforts to develop unmanned logistics systems, AIR, ULSA, in small, medium, and large sizes, including models with conventional, electric, and hybrid electric propulsion systems. The expanded use of drones for cargo transportation promises to reduce the risks associated with moving cargo by ground, as well as free up conventional aircraft for other missions. The Marines envision using small ULSA with payloads of around 60 to 150 pounds, roughly to 25 to 70 kilograms, to provide emergent and routine distribution of supplies between neighboring ground units. A UK startup, Urban Airport, has revealed plans to develop 65 electric urban airports worldwide in partnership with the Urban Air Mobility division of Hyundai Motor Group. Its first fully operational urban airport, named Air One, will be unveiled in Coventry next year. Urban Airport will change the way we travel forever, unlocking clean urban air transport for everyone, improving connectivity in congested cities, cutting pollution and boosting productivity. Urban Airport said its modular hubs, specifically designed for compact environments to support any eVTOL or drone vehicle, will be able to develop in dense urban areas and remote locations with ease of movement to alternative sites. Maintenance and charging will take place on site, with all sustainable transport, including electric vehicles, buses, and scooters, able to access charging facilities. The ultra-compact off-grid design also means the sites could support disaster emergency management with rapid deployment of drones and other eVTOL vehicles to collect and transport emergency supplies, equipment, and people. The company has also announced a partnership with a hydrogen fuel cell company to provide zero-emission off-grid power for future sites. The system will be deployed at Coventry's Air One site. So, in conclusion, air urban mobility is a new way to commute intercity and intercity. It's a concept involving vertical takeoff and landing aircraft, decentralized traffic management, and new infrastructure to support urban, suburban, harbors, and rural flight operations. In 2030, will be about 120,000 drones flying inside the city to commute people from airport, downtown, from harbor to airport, carry goods or passengers. That's, I hope in the future, for Professor Moraci to see him to use the eVTOL from Messina City to Reggio Calabria University. Thank you very much for your attention.
Thank you, Giovanni. It's really, when I see your speech, I see the future. I mean, what is the status of the project, or let's say better, when you put some dates, but when can we have the first really eVTOL flying in a commercial way in Italy?
Allora, the plan for Volocopter, Lilium, EANG, and Joby is to have a commercial flight transportation in 2024 for French Olympic Games. In Italy, I hope to have this kind of air transportation for 2026 at the Milano Cortina Olympic Games. Volocopter already flew at the Le Bourget air show in France with an eVTOL only 2 seats, but in October we'll begin a strong experimentation in an airport close to Le Bourget in France, with all the EASA teams to support the project and the development of this air transportation to get the final certification for 2024.
Okay, thank you. I don't think it's only a matter of, let's say, technology development, but also I think it's important to develop a new regulation for this kind of
it's not only to fly with an eVTOL, it's also a sort of a complete systems that has to support the flying of this electronic drone. That means that at the EASA agency already there are some working group studying and developing specifically requisites not only for the production but mainly for the air traffic management system. That it's very, very important.
And another question is about the Italian industries. What's the level of participation? Because in one slide you mentioned all the company were not Italians. I mean, there is also, I think, because in other slides I saw participation. What's the level of participation of the Italian industries in this project?
Right now there is only one an eVTOL company, is an Italian, called Manta Aircraft. They began their activity in May. They are located in Sesto Calende, and I think that in the future they will fly in an airport around Pianura Padana, not already decided, but there are some negotiations with ENAC to find an airport where to begin this flight test. At the end of this flight test, Torino Air Italia will be the first airport where all the companies will develop the system that support the entire eVTOL system, including the battery charge of the electricity field and also the infrastructure of the Vertipot.
Okay, thank you. Is there any other question?
Yes, Eduardo De Francesco. In Rome, we are promoting actually an initiative about the OverMobility, but in this case we are speaking about river and fluvial, river and coastal problem, because the theme is very similar. Again, authorization, certification, control, electrical engines, batteries, most of them are really common. So could be interesting to analyze if more some of those terms can be shared in some way. I hope that after my presentation we can restart with this discussion just to be more oriented on the theme.
Yeah, absolutely. For just to remind you that the flight test pilot for the Manta company will be Maurizio Cheli, the former Air Force test pilot and also astronaut.
Okay. Any other question? Okay. Before I go to the next, I would like to salute Colonel Gigante. Welcome on board. Okay. So.
Hello, everybody. Good
Ciao,
afternoon to
Nicole.
everybody. Buongiorno.
Good afternoon, because where are you? Tell us.
Actually, I'm in Seoul, and the time is now 17:36. So
Okay.
it's quite late in the afternoon. Good afternoon to everybody. Actually, good morning to everybody. It's very interesting. Sorry, I joined just too late. I had another meeting, and I salute my padrino, General Nicolella, and General Saboldelli Pedrocchi, who were together when I was very young, Orione the Fourth.
Okay.
I was defense attaché in Seoul almost 16 years ago.
I'm following your steps, sir. I bet it's quite different right now, because Seoul is like a fantastic capital of 25 million people, and the progress is fantastic here. It's everything high tech. It's beautiful. It's even better than Manhattan. But we'll see. It's a nice experience, and we're learning quite a lot. Thank you so much.
Thank you, Nicola. Thank you. So, Eduardo, the floor is yours. You are going to speak about use of an advanced amphibious rover as a multi-purpose geo-referenced sensors carried. So, okay. Eduardo, please.
Good morning, everybody. And I'm going to share something. The screen, everything. Okay, you can see the screen?
Yes, we can.
Okay, so very shortly, we are speaking about, yes, sorry, I'm starting. Okay. SETEL was in the aerospace since 1973, and now we are presenting our multi-purpose amphibious rover, which is the object on the left down. I have a short video that I hope could be more effective than my speech. Should be on the screen. Okay, you was able to see the video. Coming back to, so this is a short presentation trying to give you a feeling of what we are speaking to. And in synthesis, this is an amphibious vehicle. It can move in many ambient land, water, lagoons, nuts, snow, and so on, but not changing the shape. This is important. It's able to go everywhere surface, liquid or solid surface, or intermediate surface, without changing its shape. It allows to be precise operating with the geolocalization, and can transport about 300 kilograms of instrumentation or space for sampling or something like that. So, are you there? No?
Yes, yes.
Okay, okay, sorry. Back to the presentation. Okay, so this is very shortly our object, and I would like to stress the elements: land, water, mud, snow, precision task, multi-sensor instrumentation. How it is made? Basically, this is a patented application. 2 wheels, some weights, electrical batteries, a capability to rotate, the center of gravity extremely low, and you can decide the propulsion, the direction, 2 wheels, two propeller, and cannot be being very low center of gravity is very stable, and it's in some ways sort of random, so it can contains internally everything about electronics, antennas too. Just have to expose the sensor which needs to interact with the external ambient, like cameras or object to pick up chemicals or to sprinkle. Many applications: agricultural, geological, perimeter surveillance, structural inspection, hazardous exploration, small logistic payloads. There are some slides about this later. And the main points are inherently stable, energy efficient. You have to consider actually the agricultural version we are starting from use about 500 watt to run, and have an autonomy of about 12 hours. Basically, it's low-cost design. It's high reliable because it's very simple, so it's high reliable. It's amphibian. It's also the relation between power and the weight allows for strong acceleration, can turn high speed, very high mobility on spaces, low pressure footprint is very important for mines also, but for agricultural application. Okay, so those are the main characteristics of these objects. Application of these, I don't mention too much the agriculture because it starts from agriculture, where we reached now a reasonable experience, sensors, actuators. Well, this is important. Calculation process capability. In respect to the aerial drones, we have power, we have space and weight. So we allow for processing capability on board. For instance, in the agricultural field, while the aerial drones needs to come back to home to deliver the data, we can process the data in extracting parameter and deciding the operation directly on board. Data tracking, we can trace everything in the plants. And okay, very shortly, let's go on. And we are involved actually in two European programs for this object. Oh, the main application, I think, in the military field could be the patrolling of mixed area, both terrestrial or amphibious or sea. Let's think, for instance, the AFCEA riverside. You can go on the riverside, going in the river, going in the mud, and comes back to the ground. We're speaking with airports. Airports cannot allow the aerial drone to fly. So this object, which is able to be autonomous, to run, can be applied to the surveillance of the airport. We're speaking with more pens actually. And okay, this is fantasy, but I speak about this in Qatar recently, about the possibility to survey the offshore plants. This real, you can place on board the infrared for anti-thief and night surveillance. Okay, strange areas, but on the sand we go very well. And some other applications, aquaculture, mussel culture. In the mussel culture, for instance, the height of the water is such that you cannot go with the car, you cannot go with the boat. In this ambient, we are ideal. Okay, Comacchio, snow, last mile delivery, flood relief, and this is another important area for our rover. Okay, and this is again. We are harder working on the rover, enhancing its capability, and we are looking for to transfer from terrestrial to maritime application the technology. Then I'd like to stress one point, because I think this is could be important. In the water, our drone is able to orient the thrust. And being the thrust centered on center of gravity and center axis, you can have a steerable thrust with no leeway, no secondary effect. I worked a lot on mine hunters, Thailand mine hunters, so I know the complex system to let the ship maintain the ship position. This can operate in such a way that we can compensate the leeway, and consequently we can have the 5 centimeter, 10 centimeter precision in the water, orienting and modulating propulsion exactly in opposition to the vector that represents the leeway. We call it MAR, multi-purpose amphibious rover, and we are looking for application where our back to leeway is easiest. We are a carrier of sensor. We can carry processing power, and we are looking for cooperation. Thanks. Too short.
No, I think short but interesting, Eduardo. Okay, is there any question? Okay.
Okay.
So thank you very much, Eduardo. And now I give the floor to the last speakers, Professor Oliveira from Portugal. So Professor Oliveira, the floor is yours. Okay.
Hello, everybody. Good morning. Thank you for the opportunity to be here talking with this audience. Are you hearing me?
Yes, we do.
Okay. Let me share my screen. Just a minute. Okay, so can you see the presentation?
Yes, we can.
Okay, let me have it as full screen. Just a minute. I don't know why it's not going full screen. Let me see.
Okay, maybe you can share the entire screen. Not
Okay,
all.
I think now it works. Is it okay for you now?
No.
No? Let me try again, sorry. Okay, can you see?
Yes, now we can see it.
Okay, so let's go. Sorry for the technical problem. So once again, good morning. Thank you very much for the opportunity to be here talking in the military metrology for the sea. My name is Alain, and today my talk is about the convergence of cyber, electronic and kinetic warfare through naval sensors and systems. It's not moving to the next slide. Let's see. Okay, so just let me introduce myself to let you know my background and also research interests. I hold a PhD degree in informatics from the Federal University of Rio de Janeiro. Currently, I'm a professor in the Faculty of Science of the University of Lisbon. And before that, I was with the Brazilian Navy, where the beginning was military, and then I quit the active duty and went to start to work as a professor of cyber warfare and electronic warfare subjects. My research interests are cybersecurity, cyber physical systems, industrial control systems, naval and defense systems, and intelligent systems. The agenda for this talk, first I will briefly talk about some reference cases, and then we'll see a bit about the cyber domain in the naval environment, and then we'll have a discussion about threats that can interact with the cyber, the electronic, and the kinetic domains. We will characterize these domains and see how a threat can affect them in different ways. And finally, some conclusions. So about reference cases, the first one is a well-known case, an emblematic case, that is the Stuxnet worm. This is a malware that affected, from the cyber domain, it affected the physical domain. I mean, affected physical systems, directly affected the real world. And the target was the uranium enrichment plant used in Iran. Basically, the idea of the malware was to first affect Windows machines. After reaching those machines, it used it to modify the control algorithm installed in PLCs, their industrial equipment. And after modifying that code, it was able to start to manipulate the physical process, the behavior of the target, that was the uranium enrichment centrifuges. And differently from the common threat that we see in the cyber warfare, that is, for example, denial of services. Here the strategic purpose was to deny nuclear weapons, or denial of nukes. We see here there is a very important example of cyber warfare, but it didn't occur in the naval environment. But since we have this kind of equipment currently being used in the naval environment, we can think about other possibilities, such as this example that we find in the literature and in news. It is the case of a mobile offshore drilling unit that was affected in 2013 in the Gulf of Mexico. Basically, infected files were downloaded, and after infecting the system of the drilling unit, the mobile offshore drilling unit, the consequences was the loss of communication with navigation system. Then the thrusters were immobilized. It paralyzed the rig, and because of that, the rig started to drift away from the drilling site. So we can see a similar threat able to affect the physical behavior of a plant, and now in the naval environment, which can produce important consequences such as environmental implications. We can have a loss of lives, possibly lose lives, and we can have equipment being damaged. So this is how a cyber physical threat can affect the naval environment. Another case that I bring here for the discussion is related to a cyber threat affecting sensor system. So it occurred during the Operation Orshad in Syria, 2007, and according to the literature, well, Israeli jets bombed suspected nuclear installation in Syria. We have here the before and after. But the interesting thing from the point of view of the cyber warfare is written here, for example, in this paper, The Hunt for the Kill Switch, published in the IEEE Spectrum. We can see this explanation in other references also, but according to the authors, the jets were not detected by the Syrian air surveillance system because of a kill switch, a hardware Trojan installed in the computers of the radar system, and that kill switch, they were able to trigger this kill switch through remote command, possibly sent through electronic warfare means. Okay. Again, this case didn't happen in the naval environment, but since we have in ships a lot of sensors, we can think about sensors being affected by malicious actions such as GPS jamming. We have this example that occurred according to, again, news and literature in South Korea in 2016. Here, the GPS signal has been blocked, and if we think about the AFCEA model from the cybersecurity, the availability of navigation equipment was affected, and because of that, a lot of vessels, fishing vessels, were not able to locate themselves, or they had difficulties to do that, and some had to return to port, which represent economic losses. So we have situations of attacks affecting physical systems. We have situations of attacks affecting sensors. And if we think how ships are nowadays, with a lot of these equipments, we need to take care about the cybersecurity and the security of the assets of the ship. Okay, so moving a little bit forward, talking about the cyber domain in the naval environment. Today, ships are adhering to global trends and they are more and more using smart sensors, equipment that are also in the industry 4.0, having IoT devices. So we can see here a lot of operational technology, PLCs, SCADA systems to control propulsion. We can have cargo control systems, dynamic positioning systems, and these systems can be integrated with navigation sensors through integrated navigation systems. So we have a lot of digital technologies installed on ships that may represent opportunities for attackers. If we think about threats affecting information technology, the risks usually can result in financial losses, impact on the reputation of the enterprise. However, when we are talking about operational technology, the risks can also be financial and impact on the reputation, but also it can cause death. It can affect facilities, equipment, and also produce environmental impacts. Okay, and how these threats can go inside ships. So the boarding of threads, of digital threads, can be through wireless connections, through removable media. So sometimes we think our asset is safe, is secure because it doesn't have connection to or with other networks, but we can go through their gap using removable media. Also, we can have threads boarding due to negligence or unawareness of the crew. And also, as the example of the Operation Orsha, we can have threats being installed through supply chain attacks. Okay, so once we have this first discussion about the cyber domain on ships and how threats can go inside ships, now we'll open a little bit more the discussion and talk about threats in the cyber, electronic, and kinetic domains. And to support this discussion, I'd like to show this taxonomy where we have these three domains: the cyber domain that we are discussing, the kinetic domains, and the electronic domain. So the kinetic domain, or the domain of the kinetic warfare, we can define as the real world, I mean not virtual, which is subject to changes by applying forces. The domain of the electronic warfare, it's well known. It's the electromagnetic spectrum, where we have communication systems operating. We have sensors such as radar systems. We have electronic warfare equipment. So this is the domain of electronic warfare. And we can have threats that are here in the intersection of these domains. And here we will discuss cyber kinetic threats, cyber electronic threats, and multi-domain threats. Okay, so the cyberkinetic attacks are similar to what we saw in the Stuxnet case, or the case of the mobile offshore drilling unit. And just to give one more example, I can mention this work that we showed in the Metrology, the IEEE International Workshop on Metrology for Industry 4.0 and IoT. It was in the demo track. We demonstrated a device. This is a Raspberry Pi. There is the attacker that from the cyber domain, so this is a cyberkinetic domain, from the cyber domain was able to manipulate the behavior of a plant. And basically here with this simple device, it was able to learn what the plant is and how is the model, what is the model of the physical plant, able to learn the control algorithm, and after obtaining this knowledge, the attack code was able to define which frames need to be dropped in the network in order to cause the malicious effect on the plant. And this is a small and cheap device that can also be covertly installed in a hack, for example, and hidden in a hack. This is, if we think about the naval environment, we can have these affecting ship propulsion systems. These are industrial off-the-shelf equipment currently used in industry. Okay, so it can affect ship propulsion systems, weapon systems, depending on the architecture, offshore and oil and gas systems. So this is one more example of a cyberkinetic attack. About the cyber electronic attack, let's see how a digital radar system works. So basically, it transmits pulses to the environment, collect the echoes, and these echoes are converted and coded as bits in a memory. So if we have a malware or malicious entity here previously installed in the radar computer, this malware can keep monitoring what is happening in this memory, and depending on what happens here, it can understand that information as a command, as a code to start a malicious action on the radar system. And how can an attacker can send commands to the malware if the system maybe is air-gapped, does not have connection to other networks? So we can think about an electronic attack transmitting forged pulses to the radar system. These forged pulses will be represented as bits on a memory, or maybe represented as a pattern in the screen that can be used by the malware to start a malicious action, or can be used by the malware as a command to start the malicious action. And what are the target examples for this attack concept? Radar systems, radar and automatic information systems, integrated navigation systems, and so on. This kind of systems that we find also in the naval environment. Here is one work where we show how it can happen, and just to explain it better, we can use the analogy of this attack with bots in the context of network security. So in the network security, bots are sent by hackers to victims. Once the bots are installed in the victim's system, the bots wait for commands from a hacker to start a malicious action on the target. Okay, so we can think in the same way when we are talking about this attack concept, where first the attacker can inject a malware in a radar computer, and this injection can be through removable media or through a supply chain attack, as we saw in the case of the Operation Orshad. Once the malware is installed in the target, the attacker then can send commands when is the best opportunity to start the malicious action. The attacker can send commands, for example, as I said, through an electronic attack, and the malware can receive this command and start the action, manipulating now the radar processes. Here in this case, we use a simple template matching technique to recognize patterns in the radar PPI screen, plane position indicator, and depending on the pattern, the malware is able to trigger a malicious action. Okay, the same thing can be, the same concept, the same attack concept can be applied to AES ACDIS system, where we have here, ACDIS is electronic chart display and information system. We have here an electronic chart, and we can have the AES information of ships. So once the malware is previously installed on the ACDIS computer, the attacker can send forged AES messages to the AES receiver, and it's not difficult because currently AES doesn't have security mechanisms such as authentication or ciphering. So the attacker can send fake messages. These fake messages will be represented as ghost ships here, and if we send it in such a pattern that the malware can understand as a command to start a malicious action, so we can have this attack concept also applied to AES ACDIS system. Okay. And if we put everything together, we can think about a multi-domain attack. So in a multi-domain attack, we will have the cyber component acting as a pivot between the domains of electronic and kinetic warfare. So here we have an integrated bridge system where we interconnect sensors, we interconnect control systems used to control rudder, engine, thruster. So here the malware can be used to receive commands, for example, through electronic attack, process and understand these commands as information to start manipulating the physical plans of the ship. Okay, it can be considered attack strategy to communicate with a malware when the system doesn't have connection to other networks. Okay, so the attacker can use it at the best opportunity to start a malicious action. It can be, for example, when the ship is navigating through a canal or something like that. Okay. So just some conclusions about this discussion we had. Marine systems are following global trends. They are using equipment and technologies similar than in Industry 4.0, using IoT devices, smart sensors, and the boarding of threats can be through different means, through wireless networks, through removable media, or caused by unawareness from the crew. It can be exploiting a supply chain or through a supply chain attack. We need to think about cyber attacks interacting with other domains, with the electronic warfare domain and the kinetic warfare domain. And it's important also to think sensors as open doors for these situations that we talked during this presentation, where we have commands being sent to the malware through a radar antenna or, for example, AES receiver. So this is the message that I'd like to share with you. Thank you again. Thank you very much for your attention, and I'm available for questions. Let me give back the word. Okay.
Okay, Thank you.
Welcome.
Is there any question? Okay, thank you very much. You mentioned sensors, but
Yes.
have you used cryptography? I mean, this can be maybe not completely, but in largest part, solved by using cryptography through the channel. What do you think about this?
Well, thank you for the question. When, for example, we are talking about radar system, basically, let me go back to the figure here to explain. So, for example, we are talking about a radar as a sensor. Basically, what happened here, I'm not here mentioning radar interconnected to other radar systems through networks. I'm talking about one radar system on a ship, for example. So when the radar system send the pulses to the environment and receive it back, it stores whatever echoes it considers a valid echo, and we don't have ciphering here in this part, okay, of the system. So this information, if it's if we have false pulses transmitted from an electronic attack, these false pulses will be received by the radar system and written in a memory. So this information can be used by the malicious code to start a malicious action. Okay, and here we can't use cryptography, for example, to avoid the electronic attack. So this is the idea. Of course, if we are talking about radar systems interconnected in a network, when we exchange information between different computers in this network, of course, yes, we can use cryptography, but not to avoid this information coming in and this first moment to a memory to be accessed by a malware previously installed that can be installed through a supply chain attack or using a thumb drive, for example. Okay.
Okay, thank you. Is there any other question?
Dario,
Yes, please.
I want to ask to Alan a curiosity. For this type of cyber electronic attack, the type of radar is important. There are some families of radars more, how say, open than other.
Yeah, the attack strategy will depend on the radar architecture, because depending on how the signal is processed, for example, if the signal is processed using FPGA, the malware needs to be in the FPGA and needs to be, for example, coded somehow in that programmable hardware. If the radar system had it more implemented in software, so we can have the malware being developed to this other architecture, or we can have something more general that this is not, let's say, the best implementation from the point of view of stealthiness, but it's a more generic case where the radar the malware doesn't access the memory, but access the screen of the system. So in this case, it can keep scanning patterns. The malware keeps scanning patterns in the screen in order to start the malicious action. And in this case, it's less dependent on the radar architecture. Okay.
The state of art of cyber attack on naval unmanned vessel.
It's very good.
Unmanned vessels, and so it's very important your experience field. What is the state of art?
Yes, it's a very good question. Currently, it's an important. Well, this concern about cybersecurity is raising in the naval environment, because of the International Maritime Organization guideline that was released and started to be used in the beginning of this year. It's a guideline for cyber risk management in the naval environment, and it's not related to autonomous unmanned vessels, but it's more generic. Okay, but there is a lot of research about these threats in unmanned ships. Okay, so the concern now is to develop the architecture, thinking about cybersecurity since the beginning. Okay, because then after when you have everything in place, it's more difficult to change. So there are a lot of researchers thinking about this situation for autonomous vessels. So there are some research published proposing authenticated, for example, AES, which is not in place nowadays. Of course, use of cryptography during the communication if the ship is not completely autonomous, if it needs to communicate with a base station, for example. So there are research to put security mechanisms in these ships, since they will not have an operator in a lot of situations to take care and verify if the ship is behaving as it should or not. Okay.
Thank you. I was thinking to our friend and colleague Eduardo De Francesco. He presented a manned sensor.
Yes, yes.
So I think that your activity should be related with something like this.
Professor Da Ponte, you are sharp in your experience. Speaking to General Savoldelli, I think also there are many experiences that are now running. I thank you and General Colella, because you put together so many topics which looks to be different, but finally they are very well connected, as you can as I just highlighted. We had to perform a seminar, a conference on this new paradigm for unmanned vehicles, river coastal town, which has been delayed because of COVID. And I think there are many points of contact between us and the initiative of General Savoldelli. Obviously, what CSSN is doing by obviously, and if you agree, Professor, I would like to send you information about the conference we made in I hope in 2 or 3 months. COVID has changed everything about this topic, because as you highlight, while a naval system can go in radar silence or radio silence, an autonomous vehicle cannot go in silence because without communication is lost. So there is a lot of items to discuss about this problem. I think what we are trying to organize in Rome, together with the Lazio region people, is the fact that speaking about autonomous vehicle and specifically town electrical mobility, there are so many topics which are transversal. So we are inviting university to speak about batteries, motors, controls, communication, cyber security, etc., which is a whole which is identical for, in some way, identical for both ground, sea, and air vehicle. So it could be an interesting exchange of experience. Trying to you can be the vector, Professor Da Ponte.
Thank you for your comments. We are trying to realize a network of interest.
Yes, yes, and for me it's a pleasure to cooperate if possible. Yes, thank you.
Okay. Yes. If there are no further questions, this might conclude the conference for this year. I thank you. I thank all the speakers, all the organization committee, the attendees who had the patience to stay until the end. And now the appointment is for next year in on the other side of the Sicily Channel, University of Messina in Milazzo. So hopefully in presence, but anyway, Pasquale, we owe Reggio Calabria, at the University of Reggio Calabria, a conference in presence. Okay, so we maybe in the near future we can organize another one in presence. So thank you very much indeed to everybody.
Thank you, Rigorella. I'm born in Messina, so thank you for that.
I'm not organizing, it's Professor Da Ponte organizing, so together with the university.
Your suggestions.
Okay, thank you very much indeed, everybody. Let's conclude.
I catch the opportunity because we could go in Lisbon if Alan may organize something.
Yes, yes, sure. It would be a pleasure also. We keep in touch.
Okay.
Thank you. Bye.
Thank you. Bye.
Bye.
Thank you. Bye-bye.
Thank you. Bye.